I am Jude Janita, working as the assistant professor in Department of Chemistry, Government College of Engineering, Bodi Nayakanur. I am going to teach about mass defect, binding energy, and breeder the reactor. Nuclear stability. The stability is a concept that helps to identify the stabilities of an isotope. The two main factors that determine the stability are the neutron-proton ratio and total number of nucleon in the nucleus. The carbon, the 12 with 6 protons and 6 neutron, so it is a stable nucleus. Carbon, the 14 has the 6 protons and 8 neutron, it is unstable. Mass defect. The actual mass of an isotope of an element is less than the sum of the masses of proton, neutron and electron present in it. This difference is called mass defect. The mass defect is nothing but the loss of mass during the formation of the nucleus of the isotopes. We can find the mass defect by applying the formula is total mass of proton, neutron and electron minus experimental mass of the nucleus. Experimental mass of the nucleus is the actual atomic mass of an atom is determined experimentally. Examples of the mass defect. To find the mass defect of the helium, the atomic number of the helium is 2, mass number is the 4. Del M equal to atomic number of helium into number of the proton plus mass number minus atomic number, 4 minus 2 is 2 into number of neutron, that is 1.00866 minus actual atomic, the mass of the helium is 4.0026. So the mass defect value of the helium is 0.02926 atomic mass units. Calculate the mass defect and binding energy for carbon 12 nucleus. Carbon 12 has 6 protons, 6 electrons and 6 neutrons. We can find the mass of nucleus by applying the mass of 6 proton and mass of 6 neutron. Substitute the value, we can get mass of nucleus. Then we can find out mass defect values. So then subtract the value m minus m dash. So the mass defect value of the carbon 12 is 0.098931 atomic mass unit. Then we can find out the binding energy, multiply the mass defect into 931.5 milli electron the volt. So we can get the binding energy value of carbon is 92.15 milli electron volt. Binding energy. The energy released when constituent nucleons combine to form a nucleus is called binding energies of the nucleus. The binding energy formula is del E equal to del mc square. Del m is change in mass, c is the speed of light. Calculation of the binding energy. The mass can be obtained from the mass defect equations. The binding energy E equal to del m into c square. Del m is the mass defect. By applying the formula of the mass defect is ZmH. Z is the atomic, the number of particular atom. mH is number of the proton plus mass number minus atomic number. N is mass of neutron minus actual atomic masses is determined experimentally. C square is velocities of light. Binding energy, the curve. A plot of binding energy per nucleons against the corresponding number of nucleon in nucleus. Helium the 4, carbon the 12, oxygen 16 are quite high in the graph, indicating the higher the stability. Then ion the 56 has much higher the stability and higher the binding energy than uranium the 235. This means that the energy the needed to separate the nucleon from each other in the ion nucleus is higher than that needed in the uranium nucleus. Binding energy the curve. The main features of this the curve is the binding energy the per nucleon is practically constant. Binding energies of the nucleus of intermediate elements with a mass number is 50 to 150 or higher than those of the heavier element. Breeder the reactor. A nuclear the reactor that generate more fissile material than it's consumed. This reactor can be fueled with more commonly available isotope uranium the 238 and thorium 232 as opposed to the rare uranium 235 which is used in conventional the reactor. Uranium the 238 is bombarded with neutron to form fissionable isotope of plutonium 239 with elimination of electrons. This plutonium the 239 is react with neutron to form the fission product and elimination of 3 neutron. Reactor the core is made up of uranium the 235 which is surrounded by uranium the 238 which is immersed in liquid sodium. The water is heated by the reactor core. In breeder the reactor, liquid sodium is used as the coolant. The steam emitted from the water goes to the turbine. The hotter the steam, faster the turbine rotates. As the turbine rotates, the electricity is produced from the generator. Breeding the plutonium. The bombardments of uranium the 238 with neutron that triggers the 2 successive the beta the decay with the production of the plutonium. The amount of the plutonium produced depending on breeder ratio. Significance of breeder the reactor. The fissionable nuclide like uranium the 235 and plutonium the 239 are called fissile nuclide. Uranium the 238 and thorium the 232 is called fertile nuclide. Plutonium the 239 is the man-made secondary the fuels. Advantages of the breeder the reactor. Breeder the reactor does not require moderator and gives high power the density. The sodium is used as the coolant, need not to be pressurized. Then reactor the size is small. Disadvantages of the breeder the reactor. The initial the cost of the fuel is very high. The handling of the sodium is very difficult. The thermal distress create the problem. Thank you.